Hello everyone, I am Pankaj Singh welcoming all of you on this Drishti online platform. Today we are going to do the 8th episode of 100 most important topics for prelims. For starting this 8th episode, it is very much important to do the questions that we are doing what 7th episode. So the first question that and then question it is based on the topic of heat budget of the earth, insolation, albedo, urban heat island, atmosphere, basic composition, layers of atmosphere. Let us see the first question here. Consider the following statement regarding the Earth's heat budget. The Earth maintains thermal equilibrium through a balance between incoming short-wave solar radiation and outgoing long-wave terrestrial radiation. Yes, that's the correct statement. And approximately 35% of incoming solar radiation is reflected back into space, which is known as albedo. Yes, around 35%. It is the correct answer. And you can say the third statement, the entire absorbed solar radiation is retained permanently by the Earth's surface. No, it is not permanently retained by the Earth's surface. Slowly and slowly, whatever it has been, whatever the sun rays which are coming onto the Earth's surface, slowly and slowly, in the form of radiation, in the form of conduction, convection, latent heat of evaporation, condensation, it is used to back into space. So this is a wrong statement, and on the basis of that we can say that option A, 1 and 2 only is correct. Now the next question that we have to see, consider the following statement regarding insolation. The insolation refers to the solar radiation received at the Earth's surface. Yes, it is an amount of solar radiation which is coming onto the Earth. It is known as what insolation. Insolation is maximum at poles due to the longer duration of daylight in the summers. No, it is not maximum at poles. It is near to the equator in tropical regions. So therefore, it is a wrong statement. The angle of incidence of solar rays. The angle of incidence of solar rays affect the intensity of insolation. Yes, that angle of incidence. If I am saying that angle of incidence is vertical and near to normal one, it will be more heating. If it is becoming in a slant, the heating intensity keep on decreasing. So this is a correct answer. So we can say that option 1 and 3 is correct. So A, 1 and 3 only is correct. And next that we are watching, consider the following statement regarding albedo. Albedo is the fraction of incoming solar radiation reflected back into space. Yes, that albedo is the fraction, that amount of sun rays. Suppose 100 is coming out, and out of 100, 35 is returning back without any use from the I said, that atmosphere, top of the atmosphere and different space. So that is known as I said that albedo. So it is a correct one. Surfaces like fresh snow and clouds have low albedo. No, that the surfaces like fresh snow, it has a very high albedo. It has a very high albedo. Highest albedo on the Earth's surface is surface of the snow, but it is melting at present now. So wrong statement. So it is saying it is in a low albedo, and but it is in a wrong one. And third statement is talking about oceans have high albedo, therefore reflect most of the incoming radiation. The oceans have high albedo. No, we can say that ocean has a low albedo. It absorbs most of the heat. Ocean has on this earth, ocean has a very low albedo. It absorbs most of the heat. So it is in a wrong statement. So we can say that statement C, on 1 only is correct. So now consider the following statement regarding urban heat island. Urban areas tend to be warmer than the surrounding rural areas due to the human activities and surface characteristics. That's a correct one. You know that the kind of building, the kind of roads that the human being has created, and all these things, skyscraper buildings and all, so it is help in trapping the more heat and causing urban heat island like. So second statement, high albedo surfaces like concrete, asphalt are major contributor to you can say that contributors to urban heat island effect. And is wrong statement, because I can say that the concretes and asphalts which are on the roads are there, they have a very low albedo, they absorb more heat, and it help in increasing the salinity, increasing the heat effect of our urban heat island. So heat effect of the urban area. Therefore we can say that this statement is wrong, because high albedo means reducing the heat and the low albedo means increasing the heat. So this statement is wrong one. urban heat island effect is generally more intense during night time. So it is more intense during night time. Yes, during the night time it is the most intense, because in the night time it releases the heat because of the urban kind of structure infrastructure which has been developed. It is generally releases the heat very slowly, and the surrounding area of the village or the other rural areas which is much colder and it is much warmer. So therefore we can say that it is an urban heat island. It is more intense during night time. So we can say that option A, 1 and 3 only is what correct. Consider the following statement regarding the composition of air. Nitrogen is the most abundant gas in the atmosphere and helps in diluting the oxygen. Yes, sir. It helps in diluting the oxygen. This is a correct one, because you know that the 78% nitrogen and then 21% oxygen. If the oxygen percentage is more, then it will cause more combustion and more heating, more kind of burning kind of effect. But it is an oxygen is 21% more nitrogen, it is there 78% somewhere. It is diluting the combustion effect of what oxygen. So this is what I said, that correct one. Second statement, oxygen supports combustion and respiration. Yes, oxygen supports at the same time what I said, respiration of the organism, human, everyone, and then also burning. So this statement is what correct. Carbon dioxide is the most abundant greenhouse gas in the atmosphere. Yes, carbon dioxide is the most abundant, the large amount of what greenhouse gases which is available in the atmosphere, causing again more heating and global warming. So here we can say that the third statement is also correct. So carbon dioxide is the most abundant greenhouse gas. It is talking about the greenhouse gas, the atmosphere, and we can say that option D, 1, 2 and 3 all are correct. And now next one that we are watching, consider the following statements regarding layers of atmosphere. You know that all weather phenomena occurs in the troposphere. Yes, maximum tropical cyclone, temperate cyclone, any kind of, I said that cloud formation, thundering, each and everything taking place, all weather phenomena which is taking place in the troposphere, and therefore we can say that the lowest from the earth to the somewhere it is written 12 kilometer to 15 kilometer, and but it is in higher at the you can say that equator. So it is in a correct statement. The ozone layer is primarily located in the mesosphere. Ozone layer is not located in mesosphere, it is located in stratosphere. So this is wrong one. That third statement, meteors burn in the mesosphere due to the friction with the atmospheric particles. Yes, this is the right one. That it helps, the mesosphere helps in protecting the earth from the coming unwanted meteors. So by burning it into its atmosphere by the friction. So this statement is correct, and we can say that option C, 1 and 3 only is what correct. Now let us see, consider the following statement which has been asked in the UPSC 2024. The atmosphere is heated more by incoming solar radiation than by terrestrial radiation. No. So terrestrial radiation has an the earth which is radiating terrestrial radiation, it is in a long wave radiation, it is an infrared radiation, and its power is very less. So then it is absorbed by the, I said that atmosphere, then it is absorbed by this terrestrial radiation is absorbed by the atmosphere and causing more heating, but it is written in a reverse. So it is in a wrong statement. Not incoming by the atmosphere is heated by incoming solar radiation. No, it is heated by the terrestrial radiation, and we can say like can say that the statement 1 is what we can say that wrong. And then statement 2, carbon dioxide, other greenhouse gases in the atmosphere are the good absorber of the long wave radiation. Yes, and it is a good absorber of the long wave radiation. Terrestrial radiation is a long wave radiation, and these greenhouse gases are absorbing it and help in causing global warming. So this statement is what we can say that correct, and the statement 1 is incorrect, and then statement 2 is what correct. So the option D is, you can say that correct option for this. Another one, I consider the following statement asked in the UPSC 2024, the statement 1, the thickness of the troposphere at the equator is much greater as compared to the poles. Yes, this statement is correct, because at equator, you know that the heating of the sun rays is very high, then the warm air or warm water vapor keep on convecting upward. Due to upward convection, it goes up to the, I said that somewhere 16 on an average 16 to 18 kilometer height. And at the poles, you can be able to say that there is no convection. It is in a very colder region here that is an 8 to 10 kilometer troposphere exists. So we can say that the troposphere is very higher at equator. So the thickness of the troposphere is equator is much greater as compared to the poles. This statement is correct. Statement 2, at the equator, heat is transported to greater heights by the strong convection and currents. Yes, heat is transported in the form of warm air and warm water vapor, which is going upward. Therefore, it is I said troposphere is thicker. So this statement is also correct, and the statement 2 explain the statement 1. So both the statement 1 and statement 2 are correct, and statement 2 explain the statement 1. So this option is correct. So we have seen about it, and now we are going to see it is about in the 8th episode. So we are going to do the topics like temperature variation in the atmosphere, the stratosphere and the ozone layer. We are going to see ozone depletion, the ionosphere, record global temperature, recent global temperature record, long-term trend in the global temperature record, role of El Nino in the global temperature record. So this is, I said that it was these things that you can be able to say it was in the news, and here it is in what the major important topics are. So let us start with this first. Here it is in we are going to see the temperature variation in the atmosphere. You know that the atmosphere has been divided into troposphere, stratosphere, mesosphere, and there is a thermosphere. This is, I said that troposphere. This is, we can say that it is in a troposphere, in which I said that with increasing height, the temperature decreases. With increasing height, temperature decreases. When it is keep on decreasing like that, why it is decreasing? Because of the density of air. The density of air is decreasing. The density of air is density of air is decreasing. You can say that decrease, and then there is an adiabatic expansion. More adiabatic expansion is taking place. Therefore, here the temperature is decreasing. But as it is coming into the this stratosphere or ozonosphere, and in this one with increasing height, I said that temperature increases because the ozone molecules which are absorbing, ozone molecules are absorbing. You can say that absorbing UV and UV and UV rays and some infrared rays are there. They are harmful, and because of the heat absorption, the temperature increases. So in stratosphere with increasing height, temperature increases, and we can be able to say that now after that mesosphere, in the mesosphere again the density of the gases with increasing height from the 50 to 80 kilometer, you can say that 50 to 80 kilometer, here you can say 12 kilometer, 12 to 50 kilometer. In this 50 to 80 kilometer of the mesosphere, you can be able to say that in this region, then again the gaseous density is very less, and then that suddenly the temperature has been, density decreases, and then the molecules are far apart. There is less friction between them, less heat generated. So therefore, it is in a temperature is decreasing, and it is able to reach that what you can say that minus 100 degrees Celsius. The lowest temperature in our atmosphere is the mesosphere, reaching to the minus 100. It is decreasing, and in the thermosphere, the temperature is increasing. It is reaching the 1200 degrees Celsius, 1300 degrees Celsius, because here those gases are there is in the form of atoms, and they have converted into ions and electrons. So here in this region, thermosphere, it is also known as a thermosphere. It is from the 80 to 400 kilometer. In this region, ions and electrons available, and at the same time, because of their collision, heat generates. And at when the solar radiation, their ionized solar flares are coming, they are keep on colliding, and because of the collision, the temperature is more. So in this thermosphere, the ion and their collision and electrons is very much important. So there is a decreasing in the troposphere, stratosphere, it is an increasing, and in the mesosphere decreasing, and the thermosphere it is a. So these are the things that we have seen why it is increasing, decreasing in the different zones. We can be able to say here mesosphere, the meteors, you can say that it is colliding with each other. The meteors are burning here. That in the lower part of the stratosphere, our jet aircrafts used to move, and here you can be able to say that it decreases, increases alternately. And why it is happening, that I have already explained it to you. So we can say that you have to answer this question. We have to answer this question, please. And if you'll answer this question, it will be very much helpful for you. If you are not able to understand, then go back and see the video again, this part related, that consider the following statement regarding temperature variation in the atmosphere. The temperature decreases with height in the troposphere. It has been said. Yes, you have to say whether it is right or wrong. Another, temperature increases with height in the stratosphere due to the presence of ozone. Yes, we have to say that the ozone gas, which are, I said, that absorbing UVB and UVC rays, whether it is right or wrong, accordingly, you have to answer it or not, answer it, that so whether it is right or wrong. So temperature increases with height in the mesosphere. So this is then again the temperature increases with height in the mesosphere, that you have to see whether it is right or wrong. So this question you have to answer in the comment box, and I am waiting for your answer. And let us see to the next, that the next topic, it is related to the stratosphere and then ozone layer. It is said as in some books like it is in a 15 to 50 kilometer, and somewhere it is also mentioned 12 to 50 kilometers. So it can be in a 50 to 50 kilometer, and then I can say that 12 to 50 kilometer. So these are the two things that you can be able to say, and especially in this stratosphere, in the stratosphere, what is the most important thing, that ozone layer, ozone gases are existing from the exactly more in density and more in thickness from the 20 to 30 kilometer. Here ozone layer peak ozone concentration, highest concentration, good concentration in the 20 to 30 kilometer. And what is happening in this region? In this region, then harmful UVB rays and then very harmful UVC rays, that ultraviolet B and ultraviolet C rays are being absorbed, and it is not able to come onto the Earth's surface. It is helping in the protecting Earth from the heating, and this, if this kind of rays, UVB rays, are able to reach onto the Earth's surface, there is what all organism can be affected by these rays, and there is a genetic changes, mutation can take place, and carcinogenic diseases you will spread. So it will be spread, means I said that it will be happen to the human being, and then so it is not good. So we can say that it shields from the UVB and UVC rays and prevents skin from the cancer, means carcinogenic diseases, and also it protects the crops and wildlife, everything on this earth. And we can say that it prevents skin cancer. You can say that it maintains ecological balance. Means ozone layer trying to, what I said, that absorb all the harmful ultraviolet and able to reach to the other rays which are helping in the growth of evolution of the different microorganism. Ecological balance is there, and it protects every planktons, every crops, every producer onto this earth. And you know that it is in a temperature, already we have seen temperature increases with the increasing height. So this is an important part for the stratosphere, and it is only by the absorption of what UV rays and UVC rays, the temperature is increasing in the ozone and then the stratosphere, and by absorbing oxygen molecule dissociate into oxygen atom, and then oxygen molecule, you can be able to say that oxygen molecule dissociate into oxygen atom, and this oxygen atom, what I said, that react with another oxygen atom and forms ozone, the presence of UV, what I said, that UVB and C rays. So we can say that ozone molecule formation, it is also helpful. So this ozone, which is, I said, that in the upper atmosphere, in the stratosphere, is protecting the earth, but there are some ozone gas are forming near to the ground also. It is not good for health. So I am talking about this is good, it is good for in the stratosphere. So here, consider the following statement regarding the ozone layer. The maximum concentration of ozone is found between 20 to 30 kilometer altitude. So we have to see whether it is right or wrong. Another, the ozone layer absorbs ultraviolet B and ultraviolet C radiation from the sun. Yes, again you have to see whether it is right or wrong and answer it. The ozone layer is primarily responsible for reflecting infrared radiation back to Earth. Did I discuss anything? No, I did not. Sorry, you have to see whether you have to answer. We have to answer the question accordingly. If I have discussed, then it is there. It should be there. If I didn't discuss, then it should not be there. So you have to answer this question accordingly. The next one, we are going to see that ozone depletion. Ozone depletion, you can be able to say that majorly which is taking place in the you can say that there are so many gases are there in the atmosphere, and there are many gases are there in the atmosphere. You know that and during, especially we can say that during the spring season after the winter, in this region, that the stratosphere, you know that ozone exists, and in this ozone, what is happening, the chlorofluorocarbon and other halogens, it is you can say that hydrofluorocarbon and other other halogens. All halogens are what I said that in this above Antarctica over the there is a stratospheric cloud. At a very low temperature gives a chlorine atom and other halone groups. These chlorine atom, what I said that react with ozone, and it is what I said that able to break ozone into what I said that oxygen. So it is oxygen, and this chlorine oxides, this again what I said that break themselves into the water oxygen, and that sorry here it is in the water able to break themselves in the nascent oxygen, and this oxygen and this chlorine atom is able to again dissociate, I said that ozone. So this chlorine atom keep on, I say that dissociating ozone always into oxygen. So one chlorine atom is able to dissociate, one chlorine atom or ion able to dissociate 1 lakh ozone molecule during the spring season after winter above Antarctica and above Arctic, majorly above Antarctica, and it is causing ozone hole, and then easily UVB and UVC ray can come. So it has been taken place in the what first time there is in the Vienna Convention has been taken place. Vienna Convention, which has been taken place 1985 for ozone depletion, and thereafter in 1987 there is at Montreal in Canada protocol. It has been converted into protocol, Montreal Protocol, and protocol means anything in the convention, the thing it is not binding on the nation, but protocol is binding on the nation. And after that in the 2016 it has been it has been converted as an 2016 it is in the Kigali. It is I said that Kigali is one of the capital of what can say that Rwanda country. It is in Africa, and there is people has come together and they created an agreement because of not successful of this one. Yes, it was going on successful, but not that much successful. So they have created a Kigali agreement. It is very much important. Again, you have to understand that it is so. Therefore, we can be able to say there is above Antarctica. This is your Antarctica region. It here where it is happening. Above it is an Arctic. It is there, but majorly above Antarctica whole it is there. And here we can talk about. I said that ozone molecules are there, and there is above Antarctica you can be able to say there is ozone hole is taking place, and ozone hole, and therefore the Antarctica started melting also. So here you can see that which are the gases chlorofluorocarbons were releasing and then making a chlorine atom, and from the different halogens also chlorine atom is going on, and they are what I said that dissociating ozone molecule. And we can be able to say that if the UV rays are able to come, then it will increase skin cancer risk, eye can damage to the ecosystem and all I said the ecological system. And then ozone is beneficial in stratosphere, yes or not, absorb UV rays, you must know. And there is there is a protection related some Montreal protocol that we have already discussed, and there is we are in the Kigali agreement. In the Kigali agreement, we started talking about hydrofluorocarbon, and then also we are thinking that by 2047, 80% of hydrofluorocarbon it should be released. It should be reduced. Ozone is a pollutant in the troposphere, and ozone is a pollutant in the troposphere. But if I am talking about ozone in the troposphere is a pollutant because of the volatile organic compound in the if I am talking about volatile organic compound by the combustion of fossil fuels, and there is nitrous oxides in the presence of sunlight. The presence of sunlight creates an ozone in the in a troposphere, in our atmosphere, in the troposphere. In our urban areas, you can say that it is causing, I said that it's not good. The troposphere form ozone is not good for the health, but which is over the stratosphere, it is very much good for the health. So which is for good, protecting us, you can say. And here these are the things that we have been able to say, that ozone is a pollutant, and in troposphere smog and respiratory issues can happen. So in the, you can say that in the areas of what urban areas, lots of these things you can be able to see ozone depletions. And now the next part, now question you have to see, it is regarding that. Consider the following statement regarding ozone depletion, and then option 1, chlorofluorocarbons and halogens contribute to the depletion of ozone layer. You have to answer it whether it is right or wrong. Another, the second statement we are watching, that ozone depletion is most prominently observed over the Antarctica region. Yes, the ozone depletion in the Antarctica hole, that it is talking about, whether it is right or wrong. Ozone depletion leads to increase in ultraviolet radiation reaching the Earth's surface. It is just on the Earth's surface. So ozone depletion leads to increase in. So whether which of the statements are right or wrong, you have to answer it accordingly. Now we are going to see that in the in the 80 to 400 kilometer, 80 to 400 kilometer, there is, you can say that there is a thermosphere exists, and in this thermosphere lots of ions and electrons are existing. These ions and electrons keep on, I said, that colliding with each other, and colliding with, I say that ions or ionized solar flares, solar winds which are coming, they are colliding in this region above North Pole and South Pole. There is because of that in this 80 to 400 kilometer, we can be able to see this is what you can say that from the below ground, it is suppose I am talking about in the atmosphere 80 to 400 kilometer, we can say that there is what ionosphere exists or thermosphere exists. And in this thermosphere, if I am talking about above the Earth's surface, there is what 80 to what I said that 400 kilometer. There is some electrons and then other ions are there, and these ions is, I said that colliding with each other also, and it is colliding with, I said that solar winds which are coming. It has an ionized, it is also ionized. And when they keep on, I said that they keep on, I said that colliding, large amount of heat release by what I say collision. When the collision is taking place, then the heat is released, and then therefore ionosphere and thermosphere temperature is very high. So here the temperature reaches to 1200 to 1300 degrees Celsius, and at the same time these ions, if it is, I said that these ions which is available in the atmosphere, these ions which is available in the upper atmosphere, it helps in also communication. So radio waves movement, if there is an ions are there, and what we can say that in the communication has been seen, this communication is returning back. And so in this ionosphere, there is some D layer, E layer, F layer, and in the F has been divided into F1 and F2 layer, that is known as an apleton layer. It is okay. So apleton layer, it is there. Then E is known as what? Kenley heaviside layer. Also it is known as a Kenley heaviside layer. It is a Kenley heaviside layer. It is discovered by this one. So from the 80 to 400 kilometer, the different ion concentration at different height, you can say on the basis of that there the DF layer is there, and it helps. And I said that high frequency waves to what I said that very high frequency wave to what I said that return back the form of radio waves and all. At the same time, we can be able to see like here it is there, and above North Pole, because of the collision above North Pole, because of the collision, there is what beautiful color in the sky, beautiful color the sky. And then which color in the sky, especially you can say that a green color, there is what a blue color, which are coming into the sky because of the collision. There is an ions and then sun ions which are colliding, and then this is known as an aurora. You can say that borealis, aurora borealis, and in the what north, above North Pole you can say, and I said that it is known as an aurora australis, above what you can say that South Pole. So here it is an aurora, this is what we can say that, and there is an aurora borealis, here it is North Pole. So, and at the same time, and it helps in, I said that, protecting those solar flares. There is a very harmful, very ionized, if it is able to reach to the Earth's surface, everything will burn, what I said that ash. So this ionosphere is protecting us also. So let us see about, yes, you can say that there is a D layer, E layer, F layer are there. Radio communication reflect radio waves. You can say that it reflects what radio waves, and it is a long distance signal. Satellite communication helps in the what in the satellites which are moving, and these ions are helping in what communication of it, and affects. But if there is a solar radiation, if it is more ionization, more solar flares, winds which are coming, colliding, and then sudden deflection, more heat release, at that time transmission has been somewhere affects also. And there is an aurora borealis and aurora australis. It is there in the North Pole, above North Pole aurora borealis, South Pole aurora australis, and it protects life on the Earth. It also shields from the UVB and UVC rays and prevents skin cancer, safeguard crops and wildlife. So again, it is an otherwise everything will burn into, what I said that it is burn into ash. So here we can say that solar radiation which is coming ionize the ionosphere, and there is lots of their reason of ionized gases, charged particles existing in this layer. So here ionosphere is a part of the thermosphere, already we have discussed about, reflects radio waves, not absorbs. It only reflects radio waves, has been said that, and returning back it reflects, not absorb. So here that consider the following statement regarding the ionosphere. The ionosphere is a part of the thermosphere and contains ionized particles. Yes, you have to see whether it is right or wrong. Second statement, ionization in this region is primarily caused by solar radiation. So ionization in this region is primarily caused by what I say, solar radiation which are coming and colliding. So whether it is right or wrong, you have to see. The ionosphere reflects radio waves helping long distance communication. So we have to see which statements are right or wrong, and just answer in the comment box. I am waiting for your answer. So here, and another one, I said the record global temperature. It is in the what I said that in the you can say that in the last few years it is very much in the news. What is the record global temperature? If I say the global temperature measurement means, I said that it refers to the average surface temperature of the Earth. It refers to the average surface temperature of the Earth. So in the average surface temperature of the Earth, what is the most important where the temperature are helping in the measurement? In the oceans, you can say that there is is an ocean bios are there. Yes or not? It helps in the measure the temperature and also salinity. Ocean in the ocean also, what is the temperature of the ocean rising and not? So it has been also measured in this form, and there is some kind of what weather stations are there. Weather stations also help in measuring the temperature in the whole world. Weather stations are there, and you can say that there is a satellite. The satellite, it is also giving the data. Satellites are also giving the data. So here the ocean, here the Earth surface, weather stations, satellite data, all are giving the temperature record of the over the whole Earth, ocean and the land, and the data integration from thousands of sensors and worldwide. So every weather station, bureaus, all have sensors. Those sensors are giving the about the temperature, and it is managed by who? I said that World Meteorological Organization. It is in a kind of what I said that international data collection related to the temperature it does, and then USA based NASA and National Aeronautics Space Agency. It is also helping, I said that satellite observation. It is taking a satellite observation and earth science data. So it provides the data related to the temperature and analyze it also. And then same way, National Oceanic and Atmospheric Administration, it is also belongs to the USA. It also, what I said that climatic data of ocean and atmospheric research it does, and it provides. So these three bodies, we can say that World Meteorological Organization, MO, and then NASA, and we can say that NOAA, atmospheric. are, I said that managing this data related things. So, and here you can be able to say that after the 1818, the how do the temperature is what I said that this is relating to that this one, that how do the temperature is rising. So based on this, consider the following statement regarding the global temperature record. Global temperature refers to the average surface temperature of the earth, first statement, and you have to say whether it is right or wrong. Another, NASA and the national NASA and NOAA are among the agencies that monitor and publish global temperature data. Yes, you have to say whether it is right or wrong. And global temperature is measured only over land surface and exclude oceans. So you have to see whether it is wrong, right or wrong. Now the next one that we are going to see, that recent global temperature records. Recent global temperature records. In this one, it has been measured that the July month of 2023, it is the hottest year ever recorded. Ever July 2023, the hottest year. You can say that hottest, and here it is a hottest month ever recorded in the July 2023. And then it has been also said that global temperature is rising 1.1 to 1.3 degrees Celsius above pre-industrial level 1850. Yes, 1900, what I said, that pre-industrial level, above that reason you can be able to, that not industrialization we are talking about, above pre-industrial level, that is 1850. And here 1.1 to 1.3, from that 1850 to 9, the temperature has been increased by 1.1 to 1.3. Yes, and it has been also considered as that we will be able to get it is very high. And after the 2023, if I'm saying in the last one decade, which one I say that highest temperature. So 2016 is the second highest, what I said, that a year temperature record, global temperature record. After that 2020, it is then what, third one. And you can say like yes, this is the second one we have seen, this is the third one we have seen, and here 2019 it is the fourth one, and 2017, all the hottest years after 2015. And especially if I am talking about ocean temperature, here the sea surface temperature record highs. The temperature of the ocean, which is also recording high, because of that there is an ice melting, all are going, and that is you can see marine heat waves in. So marine areas having, and I said that marine means ocean, heat waves are there. So this is the thing that we have been able to see. It is about that recent global temperature records. And here consider the following statement: the global average temperature has increased by about 1.1 degrees Celsius to 1.36 degrees Celsius above pre-industrial level, whether it is right or wrong. So we have to say pre-industrial temperature baseline refers to the period after 1950. Yes, again we have to say this right or wrong. July 2023 was recorded the hottest month globally. So these are the three statements, and we have to say which one is what I said, that right or wrong. Please answer it accordingly. And here, long-term trend in global temperature, long-term trend in global temperature record. Yes, here we can be able to say like here that continuous global warming since industrial revolution. Yes, warming pattern, that is in a continuous, there is in a what you can say, continuous increase. And then last decade is warmest on record. The last decade is warmest. And here we can say, like I said, that why is temperature rising? If you have to see why is temperature rising, the first one we can say that greenhouse gases, like you can say carbon dioxide, methane gas. And according to the, I said that Kyoto Protocol, it has been said that in the annex, okay, it has been said that the carbon dioxide is the most methane gas. Thereafter nitrous oxide, there is what sulfur hexafluoride, there is a hydrofluorocarbon, and there is a what perfluorocarbon. These are the what important greenhouse gases which are trapping the what Earth's radiation. Earth means terrestrial radiation, and again global warming is due to the terrestrial radiation which is going back. It is a long wave radiation, terrestrial radiation, infrared radiation, because it has a short wave, and it is absorbed and causing what global warming and then temperature record. So here this is a greenhouse gases are there. Human activities, you know that human activities, burning fossil fuels in the form of, you can say that several fossil fuels in time, coal, petroleum. Apart of it, from the reason of what gas hydrates are there, shale gases are there, so many things which are coming out. But to an extent, you can say that the coal and what I said, that crude oil, especially petroleum, which is the major, and after that you can say that deforestation, which is helping in absorbing carbon dioxide, that if you are removing, so the concentration of what carbon dioxide is increasing, greenhouse gas is increasing, therefore the temperature is further, we can say that keep on increasing. And why do the further temperature, you know that we have done in the last episode here, it is about the albedo. So the snow is the highest albedo. Snow is an albedo, yes or not, reflecting heat. But if the, what I said, that if the snow size, due to the melting, if the snow size is keep on decreasing, that the reflection of the heat will reduce and more absorption of the heat, and more absorption of the heat by the ocean, more melting, and more melting, more I said reduction in the ocean. So it is in a positive feedback loop, you can say that in this one, in the feedback mechanism, that ice melt, I said that decreases albedo, means absorption of what ice melt size is decreasing, so that ice albedo, the area has been reduced, the albedo is what decreasing, because it is the ocean is absorbing the more heat. So less albedo means more heating absorbed. More heating absorbed means what I said, that keep on more warming, and more warming means again ice melt. So again it's in a kind of what positive feedback loop mechanism. So again more ice melt means less albedo, further less albedo, and more warming. So this one, it is causing, these are the things which we have seen warming pattern. So consider the following statement: greenhouse gases like carbon dioxide and methane contribute to the global warming by trapping heat in the atmosphere. This statement we have to say whether it is right or wrong. Another, deforestation reduces carbon absorption, thereby contributing to rising temperatures. Next one, ice albedo feedback is negative feedback mechanism that reduces warming. Whether I said negative or I say positive, you have to see this. So accordingly, you have to answer this question. Another one that we are going to see, the role of El Nino, very important in the global temperature record. When you know that 2023 is the month which is, I said that it is an El Nino year also, and it is also the temperature is very high. So both have, yes, because of the climate change, global warming, temperature is high, and at the same time, due to the more of El Nino effect, and El Nino is causing itself more what I said, that warming. But the warming has increased the temperature, therefore the 2023 is the recorded the high temperature ever. So El Nino years itself a warmer global temperature, and 2023 strong El Nino boosted warming and combined with climate change record heat. The record heat is not only because of what we are going to see, that the role of El Nino in the global temperature. Yes, if the already temperature is more and El Nino is there, so the temperature is further more, therefore record heat, you can say. Polar regions, if I am talking about polar regions where the ice is melting, again I am saying that it is ice is melting, Arctic warming, it is happening 2 to 3 times more, 2 to 3 times more warming, and there is an Arctic amplification, means more faster it is in a melting of ice. It is reason ice melting, it is very high, and the sea level rise, it is going on in the polar regions. And there is an extreme events like high temperature, you can say that in India and in Europe, it has been seen that the heat waves, like Lu, heat waves are moving on the ground. Temperature, it has been seen that because of temperature increased in this 2023. And wildfires, we have seen that Australia, Canada, which in this region, because of the increasing the heat that in the forest, there's leaves are there, they started catching the fire easily, and then because of that wildfires has been there in the Canada and Australia, and then many regions are facing somewhere droughts and somewhere floods. This thing is happening, extreme events links are there, and then World Meteorological Organization is giving report about it, and also confirm record breaking years. So World Meteorological Organization is talking about the record breaking years that we have seen after the 2023. It was, I said that 2000 it is in a 16, 2023 highest one, then 2016. So in the last 10 years, we can say that it is in a very high temperature records we have seen. And IPCC reports, which is talking about the climate change, that Intergovernmental Panel on Climate Change. IPCC means Intergovernmental Panel on Climate Change. It is talking about, I said that recently, in the very soon, we can be able to reach to the 1.5 degrees Celsius temperature, 1.5 degrees threshold may be crossed soon. So it has been said by who? I said that IPCC. Is it okay? And the record-breaking years, it is confirmed by WMO report. So consider the following statement. El Nino years are generally associated with the higher global temperatures. That the statement is right or wrong. And Arctic amplification refers to the faster warming in polar regions and compared to the rest of the world. And then melting of polar ice contributes to sea level rise. So we have to see whether which of the statements are right and wrong regarding that. And another one, with reference to the Earth's atmosphere, which one of the following statement is correct? The total amount of insolation received at the equator is roughly about 10 times. Did I say anything that 10 times it is there? In the 10 times, did I say anything like that? So please check it out. I said that total amount of insolation received at the equator is roughly 10 times times of that of the received at poles. And statement B is saying infrareds constitute roughly 2/3 infrared. In the last episode, I have discussed about that. Just go and check it out. How much UV rays are there, how much visible rays are there, how much infrared are coming onto our surface. In the last episode, I have discussed about it. And then infrared waves are largely absorbed by water vapor that is concentrated in the lower atmosphere. You have to see this question. And another one, I say infrared waves are part of this visible spectrum of electromagnetic waves, solar radiation. These things I have discussed in the last session. So please answer this question. Is it okay? So I think we are able to see this 8th episode. So please keep on checking all the what I said, that parts of this the 8th episode. So different 8 topics I have discussed, and accordingly try to answer all the questions. And I am, what I said, that ready to watch your comments. So please and give your best preparation, and we will meet in the 9th episode. Till then.
For more informative content, like, share and subscribe, and do not forget to press the bell icon to get the notifications.